A pulley system has 3 pulleys in the fixed block. A pulley system has 3 pulleys in the fixed block and 2 in the movable block. A pulley system has 3 pulleys in the fixed block and 2 in the movable block. If the pulley has an efficiency of 72%, if the pulley has an efficiency of 72%, comma, the mechanical advantage of the system is that Alright, let me give some minutes, please. You try it out. They ask you for mechanical advantage of the system. What do you do? Number 1, they are saying a pulley system. So what do I do? I'll come back here to pulley. Here's my pulley system. For pulley system, I know that the velocity ratio is equal to the number of pulleys. But in that question, I'm seeing the fixed pulley and then the movable or the fixed block and then the movable block. For the fixed, how many pulleys there? 3. For the movable, how many there? 2. So in total, how many pulleys do you have in total there? 5. That means when it comes to that pulley now, the number of pulleys or the total number of pulleys comes from there? 5. So hence, what's the R for this pulley there? 5. That's all. So for this, I'm saying solution. Given the velocity ratio with that pulley is equal to, for fixed block I have 3 pulleys plus for movable I have 2 pulleys. It's equal to 5 pulleys in total. So my VR is equal to 5. That's all. I'm asked to find, okay, I'm also giving the efficiency E as how many there? 72%. I'm asked to find mechanical advantage. What do you do there? Recall your formula. Recall that efficiency is equal to mechanical advantage all over velocity ratio times 100%. Substitute values now. What do you get? I have that this now, which is 72%. So 72% is equal to mechanical advantage, which is what I'm looking for. So I'll call it ME all over velocity ratio, which is 5 times 100%. In the last class I said, when you have percent, this can cancel this. It is mathematically correct. Alright. What happens here now? This multiplies again, or from this I'm having 72 is equal to this times this 100 MA all over 5. From here now, I'll cross multiply. This times 1 is 100 mechanical advantage is equal to 72 times 5. This gives you 100 mechanical advantage is equal to what do you guys have? 360. Okay? So divided by what? 100. Divided by 100. This cancels this. So hence, mechanical advantage is equal to what gets it now? 3.6. What's your unit? For mechanical advantage, what's your unit? Huh? It has no unit. I mean 3.6. That's it. We said this about, so we talked about this in the last class. Said mechanical advantage has no SI unit. It gives you 3.6. Gives you 3.6. So that's the answer to this. Alright, next up please. Next one, please. An inclined plane. An inclined plane which makes an angle of 3. What here is 3 DGC. What does this mean? Huh? Degrees, not Celsius, not temperature. That just means it's a typo error, right? But that's what it's there actually. An inclined plane which makes an angle, this should be 30 degrees. With the horizontal, this should actually be degrees. We're saying 30 degrees. With the horizontal, has a velocity ratio. Of A says 2, B says 1, C says 0.866, D says 0.50. Which of them is the correct answer? Please tell me. Huh? What's the correct answer? For an inclined plane, they ask for velocity ratio. What's the answer? 2. Really? Okay. Solution. What am I given? I'm given the angle theta as being equal to 30 degrees. We said for an inclined plane that VR is equal to what there? 1 over sine of theta. That's equal to 1 over sine of the angle there. The angle we are given is 30 degrees. So what was that give us 2? Gives 2. Alright, so 2 is the answer. I have it. So A becomes the correct option. This 1 over sine. So that's what you have here. That's it. Remember the question. Now, listen up. When we discussed inclined plane, I said something. I said, when it comes to theta, what's theta? Theta is simply what there? The angle between what? The inclined plane and what? The horizontal. So I said, that's theta. Check the question here. The question said, makes an angle of 30 degrees with the horizontal. That's fine. Now, question. What if that said the vertical? How do you solve it? Let's say it makes an angle of 30 degrees with the vertical. How do you now solve it? What do you do? See a diagram again. Let's try to reproduce that diagram again. We have something of this nature. We have something of this nature. I call this drum of oil. You were here earlier when I explained this. I said you have a truck here. This one is a little car, right? This is the truck. Right. I said this is your inclined plane this way. I call it theta. So theta is what there? The angle of inclination between the inclined plane and the horizontal, that we call 30. Now, the question is this: what if they are giving you, or they say makes an angle of 30 degrees with the vertical? How do you solve that one then? They had mentioned with the vertical. Now, listen. On the normal case, we give you the horizontal, so don't stress. But then, what if? So, what if they had said 30 with the vertical? How do you solve that one? What do you do? If I have this, where's the horizontal? Here's my horizontal there. So between inclined plane and horizontal, I had that here. Now if I set vertical, what's a vertical? This is a vertical line, look like this. This becomes my vertical line. So they said find the angle between the inclined plane and the vertical becomes this angle here. So how do we get this angle? How do you get this angle? Of course, obviously here because of there 90 degrees. Yeah? Right angle triangle here becomes 90 degrees. So if they give me here as, that means if I combine, if this is 90, sum of angles they try is equal to what there? 180 degrees. If this is 90, what does it mean? It means that the angle of inclination to the vertical plus horizontal gives you what there? 90 degrees. That's the concept. Alright. Sum of angles in the triangle is equal to 180. This one alone is 90. So I have these two combined to be 90. Hence, if they say that the angle of inclination to the vertical is 60 degrees, what would this one be now? 90 minus 60, which is what there? 30 degrees. That means if I'm giving the angle of inclination to what? The vertical, what do you now? Becomes 90 minus that angle to give you the angle of inclination to what? The horizontal. That's the case there. Alright. One more question. So this is easy now. This one says, what's the relationship between mechanical advantage in bracket MA, velocity ratio in bracket VR, and efficiency with percentage? Here's the answer, right? This one here. This is actually option A here. Right. What's the relation between mechanical advantage, velocity ratio, and efficiency? That's this one here. It's that easy. Okay, take down. Next up, take down. Take down, please. If the mechanical advantage of a machine is 4, if the mechanical advantage of a machine is 4, full stop, what is the ratio of load to effort? Question mark. If the mechanical advantage of a machine is 4, what is the ratio of load to effort? These are the options. Which is correct? Huh? If the mechanical advantage of a machine is 4, what's the ratio of load to effort? Which is correct? A, B, C, or D? Let's do this one, please. How do we solve this? We said mechanical advantage is equal to 4. Please. Right? It is often easy when I solve this in class. Why? Because you're thinking through my brain. Right? When I'm solving, I narrow your decision to two things, either a yes or a no. So I do what you're thinking. I just ask you, is this correct? Yes or no? At that point, you just have your chance of getting it right is 50-50. Because you either have to say either yes or no. At that point, it's easier to know what's correct. But when I give you a question like this on your own, where you now have to think it up on your own, it becomes a bit harder. That's why it's easier to do classwork than assignments. Right. In a case like this, what do you do? Just think. I'm giving mechanical advantage as 4. They ask me ratio of load to effort. How do I set that one there? What do I know? That's the question. What do I know? We know that mechanical advantage, MA, what's the formula there? We said it's load all over effort. So I'm saying that ratio of load all over effort is equal to what there? 4. For the fact that this one is a fraction, express 4 as a fraction. 4 becomes what there? 4 all over 1. So that's 4. Ratio of load to effort is now equal to, compare these two. The load is 4. Becomes 4 is to, compare this one, effort is 1. 4 is to 1. It is this easy. That's it. They have to multiply. They have to multiply. That means if I do load over effort, it's equal to 4. 4 is equal to 4 by 1. So load is 4, effort is 1. Load is to effort becomes 4 is to 1. That's all. That's that there. Look at this one, they're not hard. Are they hard? No hard. You have to understand the mechanics of Jamb questions. I see. Right, one last question we've done for today. I've solved all the past questions for the last 10 years. I've solved them now. From last class, so this is actually a continuation of last class. This is not a new topic. Right, that's why some of you are not actually following. Because you're not there in the last class. Whichever way. Let's proceed. Let's do one more question. We're off. Alright, one last question. We're off. One last question. Let's take down. A machine whose efficiency is 75%. A machine whose efficiency is 75% is used to lift a load of 1000 Newton. Is used to lift a load of 1000 Newton. Full stop. Calculate the effort put into the machine. Calculate the effort put into the machine if it has a velocity ratio. If it has a velocity ratio of 4, full stop. If it has a velocity ratio of 4, full stop. Here are your options. You have this as 233.3 Newton. You have this as B as 333.3 Newton. You have C as 334.33 Newton. You have D as 343.32 Newton. Alright, so you try it on, let's see what you get. You try it on, let's see what you get. Alright, so case 1. Let's see what you are given. Case 1. Let's see what you're given. Sorry, solution. Alright, so let's solve this. Okay, solution. What are we given? What are we given there? Say a machine whose efficiency is 75%. So I'm giving efficiency E as being equal to 75%. That's 1. Is used to lift a load of 1000 Newton. I'm giving load L as being equal to 1000 Newton. Next up, calculate the effort into the machine. So I'm required to find effort. If it has a velocity ratio of 4, so I'm giving velocity ratio as being equal to 4. Max will find the effort. What's effort there? E. Okay, let me use E there. There's an E for efficiency. No, it's not E for distance over effort now. So can we improvise? Usually in science, there's something called this. This is actually a major symbol for efficiency in science. So since we have 2 E's, let me use one for efficiency. This is called eta, the Greek symbol. It's called eta. It's actually the generally accepted symbol for efficiency, right? So we have E and E here. Let me just get that there. So I'm giving effort. I'm asked to find effort. With this, you can see your answer right. So the question now is, how do you relate all of these stuff? What do we know? Yesterday your formulas, recall this. Recall that we said efficiency is equal to mechanical advantage all over velocity ratio times 100%. But since I'm giving, or since I have load and effort is under the concept of mechanical advantage. So I have here. Yeah? Okay? That means that, sorry, let me use eta here. Alright. So that means eta efficiency is now equal to mechanical advantage. What's the formula there? Load all over effort. That's this mechanical advantage. All over VR. That's 4 times 100%. Right. At this point now, increase values and solve mathematically. Eta is 75%, so I have that 75% is equal to, I'm giving load as 1,000, so it becomes 1,000 all over the effort, that's E, all over 4 times 100%. I said at this point, percentage can cancel percentage. Next up, work this out and find if that's all. Obviously, this one comes this way. 4 goes this way. Let me see what there. 30. Huh? What do you get there? 300 is equal to. Okay. So this one is off here. I'm left it. This 1,000 all over E times what there? 100. Have it? Okay. So what next here? This to gives you what? How do you solve this? This to gives you what there? 300. Or simply can do this. Can simply do this. Cancel 2 zeros here. It's not correct. Cancel 1, 2. Cancel 1, 2. Still correct. So the concept of solving Jamb is just, if you know your mathematics very well, that's all. Cancel 2 zeros here. 1, 2. Cancel this 1, 2. Hence I have that 3 is now equal to 1,000 all over E. How do we get E here? Simply cluster because multiply. Alright, this one is simply cross multiply. So all over 1. This and this 3E. So 3E is equal to this and this 1,000 divided by 3 divided by 3. This cancels. Means that the effort is equal to 1,000 by 3 gives you what there? 333.33. Of course, effort is measured in terms of newtons. So 333.33 newtons. That's it. Any questions? Any question? Sorry? Is that? Yeah? Up to B. This I have 2 3s here and 1 3 here. The same thing now. The same thing, it's just approximation, same thing. Alright, so this is where we'll end for today's physics. See you in our next class.